Hello everyone, here is a question from electrochemistry. The standard electrode potentials for a few half cells are mentioned below. Which one of the following cells gives the most negative value for delta G naught? We know that delta G naught is equal to minus NF E cell standard, where N is the number of moles of electrons and F is the Faraday constant, which is 96,500 coulomb per mole, and E standard of the cell is equal to E standard of the cathode, that is the reduction potential, minus E standard of the anode, that is also reduction potential. Now some instructors do write it this way, that is E naught standard of the anode oxidation plus E naught standard of the cathode reduction. Both are okay, but when you use this formula, you need to constantly change the sign, because normally the reduction potentials will be given in the question paper. Now let us just verify whether they are reduction potentials or not. Cu2 plus is becoming Cu. When Cu2 plus will become Cu? If it gains 2 electrons, then it can become Cu. That means reduction. Likewise, if you see whatever the values given here, they are all reduction potentials, isn't it? So when we use oxidation potentials, we have to change the sign of the reduction potential, which I don't want to do it. Therefore, I prefer to use this formula. If you are using this formula, make sure that you are changing the sign appropriately. Otherwise, you will get the wrong answer. Now, when delta G will be negative? Delta G will be negative if E naught of the cell is positive, isn't it? That's the only way delta G can be negative. Basically, the delta G negative is going to be decided by this single value, because N is constant here. How N is constant? The number of moles of electrons is going to be 2 moles everywhere. Now you might be thinking that here we have only like 1 mole, here we are having 2 mole. But the thing is, if you write the net reaction, so for example, for this cell, if we are writing the net reaction, at the anode oxidation happens. No matter what the cell, it is always anodic oxidation and cathodic reduction. So zinc losing 2 electrons and becoming zinc 2 plus. At the cathode, reduction happens. So therefore, Ag plus gaining an electron and becoming Ag. But to balance the reaction, we have to multiply this entire equation with 2, isn't it? Otherwise, we can't balance the equation. So therefore, everywhere the number of moles of electrons is going to be 2. So therefore, that is also constant. So the net reaction in this case is zinc plus 2Ag plus giving zinc 2 plus 2Ag. That's the net reaction. So therefore, N is constant everywhere, F is constant. So we just have to determine E cell standard. If that has a more positive value, then that is our correct answer. So let's determine the values one by one. And before doing that, let's talk briefly about the cell notation. There is a phase change here. So this is the phase boundary. So basically it means that these are all solids and these are all in the aqueous medium. And this double vertical bars indicate that there is a salt bridge here to maintain the neutrality of the solution. That completes the circuit. So once again, these are all in the aqueous medium and these are all in the solid phase. So now E naught of the cell in the first case is equal to cathode minus anode, both reduction potentials. That's the way we are going to calculate. So this is all cathode, this is all anode. E naught of the cell is E naught of the cathode reduction potential, that is Ag plus becoming Ag, so 0.80 volt minus reduction potential at the anode, so that is minus 0.76 volt. So therefore together it is 1.56 volt, because negative negative will become positive. And then number 2, E cell standard in this case is reduction potential of the cathode, that is Mg2 plus becoming Mg, so minus 2.37 volt minus reduction potential of the anode, that is minus 0.76 volt. So therefore this will be equal to minus 1.61 volt. So therefore this is definitely not the correct answer, because in the delta G equation there is another negative sign. So with this negative sign it will become positive. So it is non-spontaneous. And then number 3, E cell standard is equal to cathode minus anode. So once again minus 2.37 volt minus and then 0.80 volt. Therefore this will be equal to minus 3.17 volt. And then for number 4, it would be E cell standard equal to cathode minus anode. So cathode 0.80 volt minus anode 0.34 volt. So therefore this will be positive 0.46 volt. So here we have positive 1.56 volt, and then we will be multiplying with the 2 and then the Faraday constant. So therefore this will be most negative. Therefore option 1 is the correct choice here.